Good afternoon. We're going to continue on with our review. So our next topic is probability. So hopefully you have the handout right now, so you can just kind of follow along and add examples in as we go along. So like we've been doing the past few days, here's your need to know for the probability section of the course. Okay, so experimental probability. Again, we ran several experiments when we did this unit, but the idea that you keep repeating the same activity over and over again, record what happens, and the probability of whatever you're looking for is the number of successful trials over the total number of trials. So, for example, way back when we did the activity with the poker hands, you're keeping track of, is there one pair in this hand? And you'd count up how many times you got one pair, and it's divided by how many times you ran the experiment. So the other side of that is theoretical probability. So that's when you sit down and make, a chart or a list, think about what all the possible things that could happen are, and then what you look up for whatever you want to know about is how many desirable outcomes are there, so how many ways can what you want to have happen, over the total number of possible outcomes. So how many things or how many things are actually possible when you run the experiment. Okay. And connecting the two things here, you need to know about the relationship between them. So this is the classic multiple choice question from your test. Okay, right? The idea that the more trials you run, so if you keep running the experiment, you should get closer and closer to the theoretical probability, right? As you keep going, you will get more and more close to what it should be. Might not necessarily be perfect, but you will get really close to what the theoretical should be. Okay, the last two things, I don't have anything to add here, but one of the ways we looked at probability was setting up a tree diagram. So we're going to review that in a moment. And also making predictions. So once you know the probability of something, you can infer how often it will happen over a certain number of experiments. So here's our first example. Just have a little chart here. A car dealership has some vehicles available for test drive. Okay, and here they are. Some cars, some SUVs, some are red, some are blue. If a customer chooses a vehicle at random, what is the probability of choosing a red vehicle? Okay, so again, going back to that formula we had, this is going to be theoretical because I can see all the different things that are available there. Okay, so the first part was the number of desired outcomes. So desired outcomes, well, that's cars that are red, so that's this here. So if I add those up, I would get 15 plus 8 is 23. Okay, so my numerator is going to be 23. Okay, out of how many options are there? Well, if we add all four of these up, let's just double check here on my calculator. So I've got 15 plus 8 plus 13 plus 4. Okay, there are 40 vehicles total there. So the probability of this happening is 23 out of 40. So we can represent it as a fraction. We can't go any lower with the terms here, so that is lowest terms. Okay, we can also represent it as a decimal, and if you don't remember how to do that, okay, all that's really doing is just dividing, right? If I take 23 and divide it by 40, okay, I get 0.575, okay, which of course is a percent, is 57.5%. So there's a 57.5% chance it will be red. What is the probability of choosing an SUV? Okay, so similarly, if I count up the SUVs, 8 plus 4, there's 12 of those, and still out of 40 total vehicles, so there's a 30% chance you would choose an SUV. So for example 2, we're going to do a tree diagram problem here. Okay, and this is where just please make sure the video is paused as needed to make sure everyone's getting things down okay. A restaurant meal consists of soup or salad, fries or baked potato, and steak or chicken. So for part A, we're going to draw a tree diagram that outlines all the possible outcomes. And then for B, we'll determine probability that a meal has fries but not soup. Okay. So the best way to do this is to just look at the various choices, right? So my first option is I can do soup or salad. Okay, so I just start with that. My first option is I can go to soup or I can go to salad. Okay, my next option is, right, fries or a baked potato. So from each of these, right, I could have got the soup and then fries or potato, fries or potato. Okay, last but not least, we have the option for steak or chicken. So that goes steak, chicken, and so on. Okay, so this creates all the different possible pathways, right? I could have soup, fries, steak, soup, I don't know, potato, chicken, something like that. Okay, for part B, for probability, okay, well, the probability has fries and not soup. Well, we'll start with how many total options are there here? Well, each path, right, starting here and ending out here is a possible option. So I really just need to count out how many endpoints there are. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are 8 possible meal combinations I can make here. Okay, now for the numerator, we're just going to look at what ones I actually want. So it has fries. So it has to be, we need this, okay, but not soup. Okay, so the only pathways, so this entire section is out now. And down, so from down here, the only paths that contain fries are this one and this one. Okay, so that's 2 out of 8. Okay, which would reduce down to 1/4 if I divide both those by 2. And last but not least, that would make it 25% when it's all said and done. Okay, last, this is about that whole interpreting part. So I looked this up. The current winning percentage of the Las Vegas Golden Knights is about 71%. So if this holds for the rest of the season, how many games would you expect them to win in the whole season, which is 82 games? Okay, so really, assuming this is going to hold true, we would just expect that 71% of all these games would be winners. So we just have to calculate what is 71%, so 0.71 of 82. So I multiply those together, and that comes out to about 58 games. So if they can maintain that winning percentage, they should win close to 58 games this season. Okay, so that's the probability section. That was the first handout. Okay, so if I'm not back yet, we'll continue on with statistics. So there'll be a second handout to go out. So we're going to do statistics now. And here's what you need to know. So again, just add the things that go along with it. So the first thing we covered in this course were sampling types. So there are 6 that we learned about: simple, systematic, stratified, cluster, volunteer, and convenience. So you need to know roughly how they work, right? Like for example, that the cluster sample involves picking groups, right? Breaking your population into groups, and then picking some of those groups and surveying every person in the selected groups, right? So know what they are and how they work. Okay, we talked about the difference between primary and secondary data, right? Which is in primary, you basically collect fresh data on your own by conducting a survey or running an experiment. Whereas for secondary data, you just go to an existing source, right? You know, like the NHL website or Stats Canada or a book from the library, and pick data that someone has already collected and just use it. Okay, that is secondary data. Okay, we talked about 3 types of bias. So the 3 types we talked about in our course are response bias, which is bias coming from a bad question. Measurement bias, which is bias occurring from a poor measurement technique or perhaps a poor choice of sample. And non-response. Okay, non-response is bias created by any kind of volunteer survey. So for example, if you have an online poll that's just open for anyone to take part in, that has a non-response bias because lots of people will not see it, or they will see it and they'll ignore it. And only people who are really interested in the poll will actually answer it. Then we started talking about actually analyzing some numbers here. So we talked about central tendency, which is calculating the mean, the median, and the mode. So know what those 3 things are and how to calculate them. Okay, we did some work with graphing data. So specifically the histogram is probably the most important one. So know how to make one, right? You'll have a table, right? Do a tally chart and then use it to draw the bars of the histogram. Okay, and also what some of the common shapes are. For example, like normal distribution looks a bit like a bell curve, but we'll get into that in the examples we do this afternoon. Okay, and last 2, I don't have anything to add here, but range and quartiles, standard deviation, so just some calculations, and we'll go through how those work on the next page. So, for example 1, we're going to calculate central tendency for the following set of data. Okay. So we'll start with the mean, and that's very big, but we'll make that work. So the mean is your sort of traditional average when you just add them all up and divide by how many. So I have 2, see 2 plus 4. Okay, so when I add those all up, there's a total of 63. Okay, and I'm pretty sure I have 10 numbers in my list. So divide that by 10, so the mean would be 6.3. Okay, for the median, we go try to find the middle. Okay, this data is already sorted, so I can just look. If this wasn't sorted, if it was all jumbled up, we'd have to sort it first from lowest to highest. Okay, so my middle point here, okay, if I start going in from the end, right, 1, 1, 2, 2, 3, 3, 4, 4. Okay, there is no exact middle point. There's 2 numbers in the middle that are 5 away from the end. Okay, so that means I'm going to have to go in between those 2. So my median is 6, right? Halfway between 5 and 7. So the median is 6. Okay, the mode is what occurs most frequently, and I have 3 4s here, so that's 4. So that's the central tendency part. Okay, for measures of spread, okay, the first one we talked about was range. Okay, and range is simply the highest number subtract the lowest number. So 10 take away 2, which is 8. Okay. We also talked about quartiles. Okay, so the first quartile is found by just looking at the bottom half of the data, so my 2, 4, 4, 5, and finding its median. Okay, and there is a specific center here, it's the 4, so my first quartile is 4. Okay, and my third, or upper quartile, is found by doing the same thing on the other side, and that's 9. Okay, finally the interquartile range, or IQR for short, is just the difference between those two numbers. So 9 take away 4 is 5. Okay. The other measure of spread we did was standard deviation, and for this one you can do it by hand, but it's much faster to use the graphing calculator. So we'll grab the graphing calculators, and I invite you to review how this will work. So once you have it, first let's wipe the memory. So that's second plus 7, 1, and 2. Okay, so now we're going to press the stat button, and we're going to go to option 1 for edit, and just fill in our numbers. So I have 2, 4, 4, 4, 5, 7. Okay. Once the numbers are in the calculator, to get a lot of this information right here, we're going to press the stat button again and go over to calc and select the one var stats option and press enter, and there we go. So our mean right up here is 6.3. Okay. The standard deviation, what I was talking about, is right here, the sigma x. Okay, so my standard deviation is about 2.72. So sigma equals 2.72. Okay, and just to verify some of this stuff, I'll scroll down here. Right, my first quartile is 4, my median is 6, and my third quartile is 9. Okay, example 2. Town council wants to conduct a survey about a new park. Describe how the council could conduct a survey using a, and we'll do some different type of samples here. Okay, so first is systematic. So systematic is the one where you kind of go in irregular intervals. So they could say, okay, get a voter list and survey every, I don't know, let's say this is a pretty big town, so maybe every 30th person. Right? If that was a no one sound, that would give us, I think, about 600 people, okay, which would be quite a bit. Whoops, voter list. I apologize. Okay, but the key thing is there, right, you have some kind of a list and you go through the regular interval, every 30th, every 50th, whatever you would like to do. Okay. For a stratified sample, okay, that's when we divide into groups. So let me, I don't know what groups we'd use. Let's say we'd use neighborhoods. So divide the town into neighborhoods. Okay, those are our groups. And take a percentage of each. Actually, I should change that. Hold on a sec. Take the same percentage of each group. Maybe say if I want, well, if I want 10% of my community, it'll be 10%. Okay, and the reason we do that is to make sure that the groups are represented based on their size. So if one neighborhood, say, has 500 people in it, and a different neighborhood only has 300 people in it, if I take 10% of each group, in a larger neighborhood, we'll get 50 people, and a smaller neighborhood will get 30. So there's still balance in terms of the size. Okay, last type is convenience sample. And convenience just means take whatever is relatively available. So maybe they would just stand outside town hall and ask passersby. Okay, so you just grab people who are really easy to do. Okay, this one is biased because people who are walking by town hall probably work downtown or are shopping downtown. That creates a certain type of person. And for our final example, we're going to review some of these shapes here. So sketch an example of each type of distribution: normal, bimodal, uniform, and skewed. Okay, so we'll start with normal. Normal is the bell curve type shape, so it looks something like this. Right, it has the highest frequencies in the middle and lower frequencies on the side. That's kind of a general bell shape. Bimodal, that's the one that has two peaks. So maybe one peak here and then a bit of a dip, and it goes up again and comes back down. Okay, so again, bimodal, you know, the word mode is kind of in there. Two numbers that are very frequent. Okay, uniform means that the bars are all more or less the same height. Doesn't have to be perfect. Okay, but they're very close to being all the same. Okay, and finally skewed. That's the case where one end has a lot more data than the other. So maybe something like this. This is right skewed, and this one, let me put an R there. And this one is left skewed. Okay, so there's your brief overview or review of probability and statistics. Okay, so for the rest of the class, please continue working on your ISU or on the practice exam that you were handed out yesterday.